Hello, this is Sudha Malli, Assistant Professor, Department of Civil Engineering from Rohini College of Engineering and Technology, Kanyakumari. Today we are learn about the theory of errors, means surveying adjustments and theory of errors. So, in this topic, introduction, types of errors, and definitions, then some law of accidental errors. Intro. A typical survey measurements may involve such operations like centering, pointing, setting, and reading due to some human limitations, imperfection in instruments, in environmental changes, or carelessness. Certain amount of errors are produced. The error in measured quantities should be eliminated before they used in computing other quantities. Theory of measurements and errors, types of errors and how they begin, how to adjust them, precision and accuracy, errors and probability distribution, standard deviation as a measure of precision, error propagation, the law and how to apply it, review how to derive basic functions, the law of error propagation will be given. Error measurements are three kinds. First one is mistakes, second one systematic error, and the last one is accidental error. Mistakes. Uh, Mistakes are errors that arise from inattention, experience, carelessness, and poor judgment or confusion in the mind of the observer. If a mistake is undetected, it produces a serious effect on the final result. For example, if observer read horizontal circle of the theolite is 180 degree for 170 degree, it is a mistake. Then second one is systematic error. It is an error that under the same conditions will always be of the same size and sign. The systematic error always follows some definite mathematical or physical law, and a correction can be determined and applied. Such errors of constant character and are regarded as positive or negative according as they make the result too great or too small. Their effect is therefore cumulative. For example, the error in the length of the steel tape due to change in temperature in a systematic error. Systematic errors are also known as cumulative errors. Then the last one is accidental errors. Accidental errors are those which remain after mistakes and systematic errors have been eliminated and are caused by a combination of reasons beyond the ability of the observer to control. They tend sometimes in one direction and sometimes in the other. That is, they are equally likely to make the apparent result too large or too small. They don't follow any specific law and may be positive or negative. Then some definitions are used in this topic. Direct observation. It is the one made directly on the quantity being determined. For example, distance between 2 points is measured as 45.62 meter with the tape in field or chain. Indirect observations, value of quantity derived indirectly from direct observations, like the value of angle at triangulation station found from value of angle measured at satellite stations. Conditioned quantity, if the value of observed quantity depends on the value of other quantity, it is called conditioned quantity. For example, a plus b plus c is 180 degree. True value of quantity, true value of quantity is the value which is absolutely free from all the errors. It is classified as independent quantity and dependent quantity. Then most probable value. The most probable value of a quantity is one which has more chances of being true than has any other. It is deduced from the several measurements on which is based. It can be found when the quantity is measured a number of times. Then true error. It is the difference between the true value of the quantity and its observed value. Then residual error. It is the difference between the most probable value of the quantity and its observed values. The law of accidental errors. The most important features of accidental errors which usually occur are small errors tend to be more frequent than the large ones. That is, they are the most probable. Positive and negative errors of the same size happen with the equal frequency. That is, they are equally probable. Large errors occurs infrequently and are impossible. So, some defines the occurs of errors and can be expressed in the form of equation which is used to compute the probable value of quantity. It's a probable error of the mean, probable error of a sum, mean square errors. The formula for probable error is difficult to derive. It's a state here categorically. Probable error of a single measurement or observation is given by the formula E is equal to plus or minus 0.6745 root of summation of V square divided by n minus 1. N is the number of measurements. Then probable error of the mean value, that means E base m. M is the measurements, mean values, is equal to plus or minus 0.6745 root of summation of V square minus divided by n into n minus 1. Standard deviations. SD is equal to plus or minus root of summation of V square divided by n minus 1. Then standard error is equal to plus or minus root of summation of V square divided by n into n minus 1. Then precision, that means accurate value, P is equal to plus or minus E base m, that is probable error of the mean divided by x. X bar means it's a mean value. Okay, thank you.